Hi everyone, I'm Joseph Garod. I work at INSEE, building a data science platform, Onyxia. And you might know me for some of the libraries that I build, like Keyclockify, TSS React, or React DSFR if you work for the government. And I wanted to do this little presentation to address, uh, debate the two common criticisms that are made about TypeScript today as a language, which is first that, it's getting in my way. I can develop much more quickly if I just write vanilla JavaScript. And I spend much more time trying to make TypeScript understand that it's okay to write that to write actually productive code. And the second one is that TypeScript is not really type safe. It's just a glorified autocomplete, because you can always cast as any or use a bang to say, no, it's not null, trust me. And you're breaking the type system and losing any face or face on the validity of the type system. So I argue that these two points can be very well mitigated just by using a set of utilities that leverage keywords like assert and is. So assert is for building type-safe assertion function, and is for building user-defined type guard. And I try to show that in a couple of examples. So is it readable? All right. Okay. So here I have get Alice age function that returns a number. Here I have an array of person that is statical. It doesn't move, and it has Alice and Bob. This function find in person Alice and returns the age of Alice. Uh, Here there is something that is often seen in TypeScript code base. We use optional chaining here because TypeScript doesn't know that there is actually an Alice in the person array. So optional chaining and a bang here to make TypeScript happy. And we feel that we can do that because we know for a fact that Alice is in the array. But actually, uh, we might be wrong on those assumptions. Let's say, for example, later on, I put a lowercase here, uh, and I forget to update the get Alice age. Then this will return an undefined when it's supposed to return a number. So somewhere in the code base, there will be an exception that will be thrown, and tracing back the issue to the wrong assumption that we made on persons will be very difficult. So the naive approach here is to just like check if Alice is actually in the array, and if it's not, I throw runtime exceptions and runtime error. And this work very well. TypeScript understand via the control flow that after this lines, Alice can be restricted from person or undefined to just person. This is type safe. But in my opinion, there is some sort of an intentionality problem with this code, because usually when you throw an exception, it's because you know that something that is outside of your control can go wrong, and you send this message to the user of the function that he hasn't used the function in the proper way. Here, this is not the case. If we throw this exception, we did a mistake. It's a bug. It's for us to fix. So I don't want to read that and think, oh yeah, maybe in some circumstances, person should maybe not have Alice. No, it should have Alice, and it's a bug for you to fix. So here, nothing new under the sun. There is a very well-established construct, assert, that is meant to convey intentionality to the text that you're making. So if you just move the if condition into an assert function, and here you say, I assert Alice is not undefined. However, if you just do that without any type annotation here, we lose the ability of having TypeScript to understand that now the type of Alice can be narrowed down from a person or undefined to just a person. So this is where the keyword asset is come in handy, because you can say, just by adding this annotation, you say, okay, TypeScript, trust me, if this function execute without throwing an exception, you can hold this condition to be true. So here the condition is Alice is not undefined. So after this line, he will know that he can remove undefined from the possible type of Alice. So yeah, just by using an type-aware assertion function and asserting things as soon as you make those assumptions, you can drastically improve the type safety of your code base, because you will have much more functions that will be lying on their return type, which is the core issue. Okay, so now another example that is a bit more tricky to address is using the as any or as my type for convenience. So here I have a type person, all right, and I have a get age function that will read in a JSON file. So I have the path here as argument. I will read from the disk, pass this file as a JSON file, and well, because I know it's supposed to be a person, I say as person, and I return person.age. So like in the first example here, the problem doesn't lie if the file person JSON file path doesn't exist on disk. Well, if it doesn't, there will be an exception. Or if the file exists, but this is not a JSON, we will get an exception. The problems lie if this is a JSON, but there is not an age property on the object, because here we will be returning undefined in a function that is supposed to return number. So, and we will end up with an error that will be very hard to trace back to person actually not being of type person. So there is a very high stake each time there's entrusted data that enter your system to validate that it's actually the correct type. So you can write a function that will test if arbitrary data is actually of type person. And assuming you didn't mess up here, which is a big assumption, you have fixed the problem here if you test that person is actually of type person and throw an error if it's not. However, TypeScript doesn't understand what it means to test is person here. So this is where the is keyword come in handy, because just by replacing return boolean, if we use maybe person is person as return type, we say to TypeScript, okay, so if this function returns true, you can assume that person is of type person. And just by changing this, now TypeScript understand this. And because now TypeScript understands what it means to what the condition is person mean, you can chain it with your assert function and write assert is person, which has great intentionality, and having it checked at runtime and understand by TypeScript. But well, still, this is very much not safe at all, because there is all the chances that you mess up here when trying to validate that this data is actually a person. And even if you didn't mess up the first time, when you will update person, you will forget to update your validation. So this is very dangerous. You have to understand that this, when you label a function as a user-defined type guard for person, for example, it's very much free solo. TypeScript is not helping you to actually doing the stuff that you claim you're doing. So this is dangerous, and there is standard solution in the industry, which is to use Zod or any other library that provide the schema validation. So the standard solution, the official recommendation, is to just like get rid of your person type definition and write a Zod schema instead, and infer the type from the definition of your schema. And now you can have a user-defined type guard that checks for maybe person being actually person. So this is perfectly type safe. It's fine. But I don't know for you guys, but for me, I love Zod. And I think the API is very clever, but it feels a bit backward to have the Zod definition being the source of truth for my type. Because as good as it is, it's not as easy to reason about and to write on a Zod schema, and it's a big abstraction leaking. I don't want the abstraction of Zod taking over the base functionality of my language. So this is why I would like to have my type as the source of truth and have the schema that is uh, derivated from this type definition. But if I do that and I define my type and alongside it, I define person, um, there is no link here. There's nothing that guarantee me that my schema Z person is actually validating my type person. If I remove a name, for example, here, I don't get any type error. So I'm back in the situation where I have to remember to keep that up to date and in sync. And if I don't, my type system will be lying. So you may tell me, okay, but just like label, add a type annotation to your schema and say that it's a Zod type for person. And sure, it does protect me from some error. For example, here, if I forget to check for name, I get a type error, but I can still very well check for properties that are not declared in person. And so I only, it's a half solved problem, so it's not a problem solved. What we would like is making a type level assertion that the person type matches the inferred type of the schema. And this is very new. I don't see this often in code bases, but this is very powerful. And you can very well do that if you combine some extends keyword here. I can write, okay, assert equal. So I assert that this type inferred from the schema is the same as person. And here I have a two-way bindings that will give me an error if I had a hobby, for example. Here I get a type error that like remind me, okay, yeah, I need to update my schema to be able to keep using like, because person is the source of truth. Now I have to align my schema to the update that I made on the source type. And since now we are in the AI era, it's not very much a problem to have to repeat the definition here, because Copilot is very well able to generate just in a second the schema validation based on the type definition above. So this is very easy. So now, great, we are back where our type is the source of truth. However, this seems a bit boilerplatey to have to declare a type guard here, because if you look at it, you see that there is nothing specific to the type person in what I'm doing here. And if I am to generalize this approach to my code base, I will be declaring a ton of is person, is something, is circle, is shape. And this seems unnecessary. I would like to be able to make this assertion in line here. And still, you can very much do that with just a generic type level utility, saying, okay, I assert that person is of type person, and for this condition to be true, these have to be verified. And by this single statement, I check that person is of type person and that it's actually true at runtime. But this can seem a bit cryptic to anyone that is not familiar to the type guard. So I don't actually write that in my code bases. But what I can write, on the other hand, is just like, okay, I split the assert into two assertions. The first one being, okay, I assert that the person, that the data is actually matching the type that I want. But TypeScript doesn't understand the implication of this condition. It's not yet. So I had another assertion that is a type level assertion this time. This was never filed at runtime. That's narrow down the type of person from unknown here to person. So don't get me wrong. This is exactly the same as writing person as person here. And from here and forward, use person as person instead of person. It's just more explicit to reduce the narrow down the type of the variable that we already have. Okay, so my point is not particularly this example, whether you find it convincing or not. It's not really the point, and my point isn't either to try to sell you to save the library that I made for this utility, but is to tell you that if you don't have those kind of utilities in your code base, you are missing out on some of the greatest features of TypeScript. And I very much regret that in the release note of TypeScript, the implementation of such utilities are left as an exercise for the reader because they don't want to publish an official TypeScript utility package. They only expose type utilities. So yeah, I think that many features are underutilized, and you can, well, if you want to use TSAFE, great, but you can also very well just check out the implementation. It's always very, very simple, and you can copy paste this into your code and have those utility available to do some the kind of stuff that I just show you in those examples.